Okay, cool. So off we go. Okay, for those of you that you don't know who this gentleman is, this is Isaac Asimov. Mr. Asimov has been an infamous science fiction author who wrote more than 200 books during his career. His work has shaped the science fiction film as we know it today, inspired movies like The Terminator and The Matrix. And through his books, he envisioned and predicted the future of the 21st century's robotics revolution. Although he worked as a biochemist, his technological background and his way of learning things somehow shaped his work, and he could actually predict things like the AI revolution or the software engineering things that would come up like decades later. And if you may be wondering what a science fiction author has to do with a tech-related talk, bear with me for the next 20 minutes or so. So hi, everyone. My name is Theodore. I'm a software engineer based in Athens, Greece. And you can find me online on Twitter or GitHub by the alias Vorillas. Please do, because I'm trying to build a cult here. And today I want to share something that's one of the most interesting and creative projects of mine. So like for the past few years, I have been digging through Asimov's work, and somehow I convinced myself that our lives look alike. Not because I have any chances of writing a book, but mostly because I also love combining ideas and telling stories. And today, I'm gonna tell you my story, how I built a robot. So a few months ago, a friend of mine asked me if we could make a side project, like nothing fancy at all. A teeny tiny time tracking application. So I thought that might be a good idea, and I immediately jumped in. And since I'm a JavaScript engineer by day, we decided to rely entirely on the JavaScript ecosystem. So we used node.js for the backend, obviously, and React for the user's interface. And we launched our application. And since we had some kind of traction, we decided that would be a good idea to play around with React Native. And since I haven't built a mobile application never in my life, I thought that it might be interesting and somehow I could gain some more knowledge. So after lots of trial and error, we had our two shiny mobile applications published. And this is when our saga finally begins. You see, I truly believe that good software comes hand by hand with extensive testing. And this is something that I actually learned the hard way. So in the backend and the front end, we were pretty confident releasing code to production because we had great coverage with unit, regression, and end-to-end testing. Using end-to-end testing, we could also detect anomalies and side effects and properly document any business logic. For our mobile applications, on the other hand, we had lots of unit tests in place, mostly because our design system was the same as the web applications. We were using React Native and React, so just a piece of cake. And I repeat, zero end-to-end testing for our mobile applications. And do you know why? Okay, let me tell you why. Because mobile end-to-end testing is like walking towards an erupting volcano. Although there are some automation testing frameworks around like Appium, end-to-end testing in physical devices is nearly impossible due to the security limitations of the providers. QA engineers are fighting this problem for a very long time, and we all have to agree that mobile testing is crucial. Mobile applications are tightly bound to the physical devices, and we need to ensure some standards for our products, especially for Android users. We faced countless problems from memory leaks up to hardware limitations. Each mobile device is different from one another. We had to test by hand that everything looked okay in the devices with different resolutions and screen dimensions. We got our apps rejected numerous times because we couldn't get aligned with some devices' standards. And you have to consider that we spent countless hours for debugging, although we own a relatively simple application. Mobile testing is hard due to reasons beyond our control. You see, mobile applications are essentially gray boxed. We have some sort of control in the resources we own, and basically that's it. Thus, we can't actually establish testing flows that require interacting with external applications, like testing a login flow with email validation. It's nearly impossible to control an application that's beyond our control. So we can't actually control an email client. Furthermore, we can't even access the device settings or any operating system internals. We are strictly limited to what our application does, and that's basically about it. Even so, we tried and faced problems with our initial setup due to push notifications, alerts popping, and incoming calls. Testing frameworks are unable to tackle properly external disruptions or context switching. But if you think about it, this is how mobile devices are working, right? They are breathing and kicking, and it makes no sense to isolate our working environment just for our testing purposes. Furthermore, we couldn't track and analyze important metrics data. How many seconds does our application take up to boot? Does it feel slow on low-end phones? How much time does it take to download the binary from the App Store? What's the end user's experience with a 4G network? Does swipe feel really snappy? Does the UI feels good for the actual end user? These metrics are essential for marketing reasons, and we were completely blind at the spot. And last but not least, in most cases, we had to introduce ugly hacks in order to properly and precisely simulate gestures and tasks in the screen. Events produced by Appium are always virtual and require extensive setup. And that problem kept bugging me for a while, as I was struggling to find a proper solution rather than manually testing and debugging every single change on my phone. And back in the days, during that period of time, I also bought my very first 3D printer as I was experimenting with IoT rapid prototyping. So during a printing session, as I was watching the mesmerizing effect of hot plastic traveling through space, suddenly I had an epiphany. What if I could actually replace the printer's hot end with a stylus and trying to tap my phone? After all, 3D printers are fully programmable. They're using a language called GRBL. So basically, when we're talking about 3D printing, we're just talking about sending commands to the printer with dimensions through time and space. So I secured my phone on the printing bed using masking tape and trying to read the screen. And all of a sudden it worked. It really, really worked. I was successfully producing tapping events just by using my printer and my laptop sending commands to the printer. And I thought that it might be a good idea to try out and build an actual robot for mobile testing automation. And when someone's hearing about building a robot, they might be thinking something like the Terminator or Wall-E, but in reality, robots are rather boring. There are plenty of white papers and open source projects available with lots of different designs based on the application area. And since the robotic applications are widely used for more than 50 years, the underlying technology is pretty mature. So we can limit down our available options and we can categorize them based on their movement mechanics. So the first category are robotic arms. Robotic arms are used in industrial lines and they are pretty efficient for repetitive tasks. An example of where automated robotic arms are used is in the auto manufacturing industry. But for our use case, they're not going to work, as we want more versatile and plethoric gestures and movement. Cartesian robots, also known as linear robots, are used for a wide variety of applications. Accommodating 3 motors and a linear axis system, they move an actuator, in our case a stylus, across a 3-dimensional space. 3D printers, CNC machines, pick-and-place robots, laser cutters, plotters, all of them are based on the principle of the Cartesian coordinated robot. But although these robots are pretty accurate, they are also a bit slow, and the actual movement does not feel natural at all. And finally, our pickup for this project are called delta robots. Invented in the early 1980s, delta robots are moving using multiple kinematic chains. They are powered by 3 or 4 servo motors attached to a steady base, rotating and moving the robot's arms. Delta robots have popular usage in picking and packaging in factories because they can be quite fast, some of them executing more than 300 picks per minute. Also, the way they're moving is the closest we can get in order to replicate our thumb's movement. Luckily for us, Jason Huggins, the creator of Selenium, designed it and open sourced the Delta robot used for automation testing. This project is called Tapsterboard, and you can find it online on GitHub. In the repository, you can also find detailed instructions about building the robot, the mechanics, the programming the actual robot, and so on. So based on Jason's work, I forked his project and modified the design a little bit, mostly because I couldn't find all the components in the Greek marketplace. I used my 3D printer, bolts and nuts in order to reinforce the base and the arms of the robot. The arms are held in place using pairs of strong magnets, while the electronics are safely secured on the top plate. The brain of our little machine is running on a microcontroller. Microcontrollers are small computational units, widely available and relatively cheap, coming into the shape of a board. For Tapsterboard, we're going to use an Arduino Nano. As you can see, there are pins popping out from the device labeled with numbers. Using these pins, we can connect the motors of the robot directly to the Arduino. The device requires no external power connection as it is powered through a USB port. The USB port is also used for serial communication and programming using our terminal. And then when it comes to programming, we can write code for the board using the Arduino IDE and a superset of C++ functions. There is a vivid community behind the Arduino Foundation with lots of open source projects and prototypes available. And also the Arduino provides us with some internal functions like the setup and the loop. Using these, along with internal libraries, we can create full-blown software running on low-level devices. For example, in the code in the slide, I will blink an LED attached to the pin labeled 3 within an interval of 1 second. Using the IDE, we can write the code, compile it, and upload it to the device. And although C code works great for most cases, Tapsterboard uses another approach. Under the hood, the robot is powered by Journey 5. Journey 5 is an open source library and framework that allows us to remotely control the board from our development station using node.js code. In that manner, we can pair hardware with our web browser and thus enhance our development experience. Moreover, we can consume modules from the NPM registry or even establish a remote connection with the robot using a web server. This part is essential, as we can expand our robot using modules widely available. For example, we can use helper libraries like Lodas, or even control our robot using a WebSocket library. And last but not least, Johnny 5 can work on different boards using the same code. This part is essential, as well as hardware specifications are totally different from one microcontroller to another. With Johnny 5, we can even create a standalone robot on a Raspberry Pi, as Pi boards are capable of running lightweight versions of Linux. Finally, we can also run a Tapsterboard farm, as we can connect multiple robots under the same controlling station. Running Johnny 5 is really simple. Since we get the module installed, we can directly use it from our command line interface. The package will establish a new serial connection with the Arduino, and we can immediately start writing code. So, first things first, we need to require the Journey 5 module. Using the built-in board class, we need to instantiate a new Journey 5 board instance. When the board gets interactive, we also need to create 3 new servo instances. These ones are moving the actual arms of Tapsterboard. The kinematic calculations are a bit confusing and require lots of math and trigonometry, as we have to translate the servo rotation to actual movement in the space. But eventually, we can consume them as an independent module provided by Tapsterboard. Using the kinematics class, we can move the stylus using a helper method passing down the x, y, and z coordinates of the movement. If z is set to 0, the stylus is actually touching the screen. If all values are set to 0, that means we are touching the center of the screen. In this way, we can recreate simple taps and raise the stylus on demand. We can also add delays between taps, as we want to create more natural interactions with the screen. Swipes can get recreated accordingly, as we can move from point A to point B within a period of time. We can even use easing effects by applying a helper method in order to manipulate the steps of the movement through time. Now that our robot can effectively tap and swipe as a human being, we need to fix one last problem. We need to ensure that the robot is aware of the actual device's position on the base. Since there is no such thing as a sensor, in order to detect the placement of the phone, we need to calibrate Tapsterboard and prevent the stylus from crashing the screen. But how we can actually do that? Using a web browser, we can effectively establish a communication channel between the phone and the robot. We need to create a simple HTML grid and start moving the stylus towards the screen. Once a tap occurs, we can read the position of the stylus. Afterwards, we will raise the actuator and repeat the process 2 more times inside the grid area. In this way, we can calculate the movement steps and precisely detect the working area of the phone and the boundaries of the screen. Now that we're all set, we can start writing our first testing scenario. Since everything is in place, we can pipe the output of the robot and use the Appium test executor along with the web interface. We can establish locators for UI elements and write full-blown testing scenarios with the appropriate validating assertions. In our case, we used a REST API in order to allow Appium control of the robot. Furthermore, we can interact with popping messages or even tweak the device's settings. And finally, we are no more limited to the applications we own. We can track down the screen of the phone and run our testing scenarios against external applications, like using visual assertions. For example, in this video, Tapsterbot is interacting with my Instagram feed. With image conversion techniques, we can extract data and detect changes directly from the screen. And since there are no limitations, at all, we can manually tweak the device's settings as a user would normally do. And if you ever had the chance to read Asimov's book, I, Robot, it's also a movie with Will Smith, you will be aware of the 3 laws of robotics. This concept was firstly introduced in his 1942 short story Round Around. These laws are describing how robots may not harm the humankind by ever means, and Asimov's stories test his laws in a wide variety of circumstances, leading to proposals and rejections or modifications of the actual laws. Thereby, since the rule set is in place, we can safely go a bit wild with our creation without any fear. We can combine ideas and concepts that were recently introduced to our community. So I experimented a lot recording our user sessions, and I was able to accurately simulate the recordings through Tapsterboard. In that manner, we can write tests or simulate scenarios without writing any code at all. This achievement is really important because we're now able to debug a user sessions remotely, or even create A/B tests in an isolated environment. We can also create user groups and test beta versions of our applications on demand. Also, since taps and gestures can be expressed as vertices of coordinates through time, we can create dynamic testing scenarios using machine learning and analytics datasets. Instead of replicating our user sessions, we can now create our own artificial users on demand. We use this technique in order to simulate aggressive testing scenarios and discover side effects or anomalies of the application. It was fascinating to find out that we could group our users under personas based on how they interacted with the application and virtually test out new features without any users at all. And if you're thinking about it, we can even experiment with other cool ideas like artificial music composition on the piano. Based on that concept, we can create interaction with the real world. We have planned lots of upcoming experiments, so you just have to stay tuned, people. And finally, if you have ever tried to reach me out or read my blog or so on, during the past few years, I also have heavily experimented with accessibility applications using IoT. So using Tapsterboard was not a case that I could skip on. I truly believe that we can actually help people in need. Just imagine if it was possible to control your phone using eye movement and a web camera, or if we could develop homemade assistive hardware for people with Parkinson's disease. We can also effectively and directly help people using common web technologies and widely available hardware. And if you're thinking about it, like using your web camera, a browser, and a chipboard like an Arduino, that idea is actually fascinating. And if there's something that you can take away from this talk, is the fact that you can actually do whatever you want to do using the power coming from this community. It doesn't really matter who you are. It doesn't really matter where are you coming from. We want to give you the tools, the knowledge, and the assets to achieve your dreams. You can be whoever you want to be, and we are part of the most popular tech community of the world. And just like that, the power coming from this community is endless. So I honestly cannot predict the future, like telling you what's going to be in the upcoming months, what's going to be with the pandemic coming around, or even what's going to be with like experimenting with web technologies or the JavaScript ecosystem. But the thing is that using the power coming from this community, we can actually provide you with ideas and the actual inspiration to chase up your dreams. And as a matter of fact, we do actually care for one another, and we can help one another by any means. In that matter, the future is bright, and I'm pretty sure about that. Together, we can build our own robots, and who knows, maybe someday they would break Asimov's laws and rule this world. Thanks so much for your time and patience. Please, everyone stay safe. We now need you more than ever. And greetings from Greece. Bye.
Hey, Theodore, what an amazing talk. Thank you very much for delivering it as part of the event.
Just give me a second, because I
can't hear me. That's probably no great loss, to be honest.
So Theodore, like I was telling you on the backstage, he gave a few months ago in JS Monthly. And it was quite incredible. There is we can post a video after this so people can watch it.
Yeah. Okay, I can hear you now.
Good. So the Q&A can start. So we were just saying you gave a similar talk not too long ago as part of the monthly meetup.
Really?
I don't know.
Yeah, in JS Monthly, do you remember? We still use the Remo. It was it was about accessibility, and you're using a small device where you're controlling with your hands.
Yep.
Yeah, that was quite incredible. It was really nice to see. So because he's doing a lot of Arduino stuff, he's very innovative, and yeah, it's quite nice to see.
How do you find the Arduino stuff, Theodore? So to add context, one of the things I used to do when I worked in education outreach was teach kids to code using Arduino robots, and we found it really easy for people to get up and running with, but very quickly the advanced stuff got difficult. Have you got any comments about Arduino and how easy it is to get up and running with it?
Yeah, so the thing is that the actual community, as I said in the presentation, is really vivid. The Journey 5, the actual way of writing code for using node.js for Arduinos is as well. There are like lots of tutorials, online trainings, books, and so on. From the real boring stuff of that story, like purchasing an Arduino, it's really relatively simple. Just go to a hobby store or Amazon, eBay, I don't know, and you can purchase one for like a couple of pounds, euros, you name it. So it's relatively cheap to get started using some a tiny board and two LEDs, and that's it. You can write your first hello world.
The traffic lights. We love the traffic lights with
exactly.
Arduino stuff. It's always the hello world, isn't it? That's excellent. Yeah. So we have had a question come in. With Arduino and Raspberry Pi, there are good bits of hardware for C/C++ and Python programming with robotics. Is there any good hardware for JavaScript robotics projects?
Yes. I think there are some people around from Node.conf. So there's a project called Arduino, which is built by Gordon Williams. It's a self-funded project where he managed to actually, so basically using Johnny 5 or Python, we're not actually writing code for the microcontroller. We're just transmitting commands to the board.
Yeah.
So basically our development station is working as a client, and the board is working as a server. So we can actually communicate through the command line. But Arduino is totally different. So you can write actual code that compiles to bytecode for boards. So you have definitely to check out Arduino.
So Arduino is the place to go for JS robotics. Yeah. Okay.
Yeah.
I was intrigued. At the end of that talk, you started talking about the accessibility opportunities for the kind of tech that we're talking about here. Is there anything like that which is close to coming to market that you know about?
I have seen lots of projects, like there's a .NET project that actually uses web cameras to translate eye movement to mouse movement.
Okay.
So there's a special part in GitHub that it's actually about IoT and accessibility. So you can find out like lots of experiments and prototypes. I'm aware for some mechanical gloves that are using Johnny 5 to translate just like gesture language to actual typings on the screens. Basically, the idea is that if you have something like a tiny board that you can easily program with it, you can communicate with your mobile phone or your laptop. That's a great way of creating your own hardware. You know, you can use an accelerometer in order to translate movement to actual interacting with the laptop. So, back a few years ago, this was something like a dream for us, and it was like an established piece of technology for big corporations. But right now, there are like lots of projects out there. So, and basically, that might be a good idea for a startup or indie developers. So you can prototype your own hardware and even make a living from it. So that's actually amazing.
Yeah, and you definitely can use this stuff for prototyping. One of my friend's companies is all around taking farm data and processing it. And they did their first, I think, 10 customers just had a bunch of Arduinos spritzed around their farm. So it's perfect, like you say, for startups.
And it's perfect. If I can make a comment, it's perfect because like 8 years ago or 10 years ago, JavaScript developers were like the scripting kids, like poking around alert boxes on the browser. And right now, using the same language, we can basically do whatever you want. You can be a backend developer, a full stack developer, or even a hardware developer, which is quite amazing.
Yeah, one language to rule them all, I say.
Yeah.
Who needs that?
We have some more questions coming up. As you know, people can also vote the ones that you want to hear first. So there's a voting system, so you can choose which one you want to hear first. So like you can see now, there was one vote for the, have you got a chance to play with a Tapsterboard?
I didn't have the chance to play around with Tapster. It's, just to be clear, since Arduino is like open source, and there are like tons of boards that are like not exactly clones, but they're like based on Arduino. So they're like boards that look similar, but they're using different hardware specification. Tesla is on my to-do list.
Okay, nice. Tony, do you want to ask another question?
Sure. So we had another one come in from the audience. Thank you for this one. What are the most fascinating abilities of the Arduino boards? I've got a suspicion I know what you're going to say here, but we'll let you answer it.
I really don't know, to be honest. So I think that the idea of like remote controlling a robot with your hand is fascinating. Like,
yeah.
That's the most mesmerizing thing. The video I showed you, like using my Instagram thing, was cool, but this is cool as well. So you can actually build something like a bot that uses your Instagram without using any code or getting rejected by the algorithm. But I think that the most fascinating project that someone could come up with, it's like combining the stylus with actual gesture movement. So or trying to unlock a phone using a fingerprint. That would be awesome, like 3D printing your fingerprint. But it's based on your imagination.
Yeah. Not very secure though.
Yeah, just to be clear, I took that idea from a B-movie with Jacques-Claude Van Damme that he's trying to escape prison. So I actually took I replicated my fingerprint using just ducking tape, and it worked. Like,
is that the 2021 talk?
Yeah, that was cool.
There is one more. Maybe I missed it, but the robot does the input. How do you assert on the output?
Yeah, that's a really good question. So using Appium, we can actually assert. So we can test the application. Appium allows us to add some locators using a build that is in testing mode. So we can assert using Appium that a button was clicked or something was scrolled and so on. But for the example with Instagram, I'm using comparison testing. So I can detect the scroll movement and detect the everything that's moving or tapping on the screen. But using Appium, you can actually do real assertions, like I pressed that button, I scrolled in that view, and so on.
Okay. So are there any extensions to this? Now you've got it set up and you've got the tests running, and are you going to extend this project at all?
So the whole project is open source based on Tapsterboard, the original project by Jason Huggins, who is actually making some amazing stuff. So he tried like bots, and I'm actually thinking about using the same robot in a bigger scale in order to work with tablets or even 2 phones in sync. That's about it, because it's really hard to prototype something in that scale and debug that thing. But thank God everything is open source. So thanks for that, Jason.
Okay, so it seems like we have run out of questions. So this is where we need to start freestyling it, Theodore.
Okay.
So what's the next crazy thing that you're going to be building up? Is it more?
Since Halfstack is, I have submitted a talk that is going to be a thing in Halfstack New York in 2021 about robotics smartwatch.
Ooh.
Like smartwatch running JavaScript. I also played around with my drones that are also using JavaScript. As I told you before, the possibilities are endless, and we just need time to experiment with.
What about incorporating any sensors into it? So I know Arduino stuff gets really cool when you start incorporating magnometers and accelerometers and things like that. Are you measuring how fast the robot's moving or anything like that? Or
so the thing is that since we can we can create something like an HTML grid and detect the taps on the screen, we can detect how fast every tap works, but it's really fast. So I tried an experiment with like playing. Do you know Piano Tiles? It's a game that you're trying to tap things on the screen.
I don't, but pretend I do.
Yeah, it's something like fast tapping, and the robot can beat everyone.
Okay.
So the thing is that the mechanics of Delta robots are pretty fast and accurate, and They are used in 3D printing. They're used in industrial lines, so they're made for like quite fast and precise tapping.
Okay, so it's unneeded then.
Yeah.
Okay, we have had another question come in. What are the sensors that you would recommend for a person with a project who requires having full soil data analysis?
That's weird. Okay, so I made the project myself. So we're talking about detecting nutrition on soil, right? I guess.
Yeah, I'd guess.
So yeah, you can build your own. By the way, if you want to ping me, feel free on my tutorial GitHub. I can help you out. So I have placed a similar setup for my plants because I'm a serial plant killer. And so the thing is, you need a humidity sensor in order to detect humidity in the room. An IR sensor in order to detect how bright the sunlight hits your actual plants. And you can also use the humidity sensor in order to detect how wet the soil is. And if you search in various tech places or even eBay, you can find nutrition detection sensors that you can actually see how acid or how nutrition the actual soil is. And you can build everything up. You can connect everything up with your board. You can even use a board that connects to Wi-Fi, like ESP32 or an extension for the Arduino, and you're ready to go.
Okay, so how many soil sensors did you fry? Because when I set something up like that, I kept on watering the sensor, which isn't a good thing.
Sensors are a bit hard to fry because you're just reading data. You're not send current to the actual sensor, so it's really hard to fry a sensor. We are actually frying LEDs and I don't know, things with like solenoids and things like that, or stepper motors.
I love the smell of a burning stepper motor in the morning.
Yeah.
I think with that, we need to wrap up now, Aris, don't we?
Yeah, there is one more, but what people can do, they can meet you on a table, they can switch on the cameras and the microphone, and they can talk to you in person. Do the same thing with the sponsors. As you know, we have some prizes for you. So don't forget, we have this treasure hunt going on. So you need to go around the tables. But yeah, you can go to a table and people can come and interact with you like the way they were going to do it in a face-to-face conference. We have that ability with the conference. So yeah, feel free to go and get Theodore and ask him any questions you have.
Yeah, thank you so much.
Thank you, Theodore. Thank you.
Thank you. See you all for the next talk.
Tony.
Yeah, sure. Bye.